Right now, there is a wall around you. You can't see it. You can't touch it. But it's there, a boundary built into the very fabric of reality. Everything you have ever known, every star, every galaxy, every photograph ever taken of deep space, sits inside it. And here's the unsettling part. It isn't the edge of the universe. It's only the edge of the part we're allowed to see. So the question becomes almost irresistible. What is on the other side of that wall? Today, we're going to walk right up to the edge of everything and peer into the dark beyond it. When astronomers talk about the universe, they usually mean the observable universe, and that word, observable, is doing a lot of heavy lifting. It's the region of space we can actually detect, because light from it has had enough time to reach us. Think of it as a bubble, with Earth sitting right in the middle. Not because we're special, but because every observer, anywhere, sits at the center of their own bubble. In the next few minutes, we'll figure out exactly how big that bubble is, why it has a hard limit, and, most thrilling of all, what the best science suggests is waiting in the darkness beyond it. Some of the answers are reassuring. Others are genuinely staggering. Here's the foundation. The universe is about 13.8 billion years old. Light travels fast, but not infinitely fast. So when you look out into space, you are always looking back in time. The sun you see is 8 minutes old. The nearest big galaxy, Andromeda, appears as it was 2.5 million years ago. Push that to the limit, and there's a maximum distance from which light could possibly have reached us by now. Beyond it, light simply hasn't had time to arrive, not because nothing is there, but because the cosmic postman is still on his way. That limit defines the edge of our bubble, and it's our first clue that beyond the observable doesn't mean beyond existence. Now for a number that breaks people's brains. If the universe is 13.8 billion years old, you'd expect our bubble to be about 13.8 billion light-years in every direction. But it isn't. The observable universe is roughly 46 billion light-years in radius, about 93 billion light-years across. How can we see things farther away than light could have traveled? Because space itself has been expanding the entire time. While that ancient light was crawling toward us, the ground beneath it kept stretching, carrying its source ever farther away. Nothing is moving through space faster than light. That rule holds. It's space itself that's growing. And that single fact, expansion, is the key that unlocks everything beyond the wall. So why not build a better telescope and simply peek past the edge? Because the wall isn't made of distance. It's made of time and of light itself. The oldest light we can detect is the cosmic microwave background, the afterglow of the early universe, released when the cosmos first turned transparent. It's the deepest we can ever see with light, full stop. Before that moment, the universe was an opaque fog, so the microwave background is a curtain, and no optical telescope, however powerful, can part it. To go further, we'd need entirely different messengers, gravitational waves, or elusive particles called neutrinos. The wall, in other words, is baked into physics, which makes the next question all the more tantalizing. What does the theory say is hiding behind the curtain? Let's start with the most likely answer, and it's a beautifully boring one. The leading expectation is that beyond the observable universe lies more universe, more galaxies, more clusters, more cosmic web, looking broadly the same as the regions we can see. This comes from a principle at the heart of cosmology. On the largest scales, the universe appears uniform in every direction. There's no reason to think we live in a privileged spot with a tidy edge just past our line of sight. So the safest bet is that the cosmos rolls on far past our horizon, stitched from the same fabric. But more of the same raises an obvious follow-up. How much more? And that's where things start to get wild. In the first sliver of a second after the Big Bang, physicists think the universe underwent inflation, a burst of expansion so violent that space ballooned by an unimaginable factor in less time than it takes light to cross an atom. If that's correct, the entire region we can observe was blown up from a patch far smaller than a proton. And crucially, inflation didn't stop at the edge of our bubble. It stretched everything. So the whole universe is almost certainly enormously larger than the part we can see. By some serious estimates, hundreds of times bigger across, quite possibly far more. Picture our 93 billion light-year bubble as a single grain of sand on a beach that stretches beyond the horizon. That's not science fiction. That's the mainstream picture. Now we step onto the speculative frontier, ideas that are serious science, but not yet settled. Some versions of inflation suggest it never fully stopped. In this eternal inflation, space keeps expanding ferociously, and within it, bubble universes pop into being, ours being just one. Each bubble could have its own properties, even its own laws of physics. That's one flavor of a multiverse. There are others. The idea that everything beyond our horizon is part of a single infinite expanse, or interpretations of quantum mechanics in which reality branches endlessly. The honest scientific position is that we may never directly test these ideas. By definition, they lie beyond what we can observe, but they flow logically from theories that do explain what we see. The beyond, it seems, might not just be bigger. It might be plural. So is there an edge at all, or does it simply never end? This comes down to the shape of space, and our best measurements deliver a fascinating verdict. As far as we can tell, the universe is geometrically flat, to within a fraction of a percent. A flat universe is consistent with being infinite, with no edge and no center, going on without limit in every direction. But here's the catch. A flat measurement could also describe something finite, but so vast that the curvature is too gentle to detect, like standing in a field and seeing the ground as level, even though the earth is round. We genuinely don't know which it is. The universe may be endless, or merely so large that endless is, for us, indistinguishable from the truth. It's tempting to feel small here, a grain of sand inside one bubble among countless others. But flip it around. Every atom in your body was forged inside stars that lived and died across this cosmos. You are the universe that grew complex enough to look back at itself, do the maths, and reason its way to a wall it can never cross. And then ask, calmly, what lies beyond? No telescope will ever show us that far. And yet here we are, mapping the unseeable using nothing but light, logic, and curiosity. That isn't smallness. That's one of the most remarkable things matter has ever managed to do. So let's bring it home. The observable universe is our bubble, about 93 billion light-years across, and its wall is built from the finite age of the cosmos and the finite speed of light. Beyond it, the most likely answer is more universe, looking much like our own. Inflation suggests the whole is vastly larger than the part we see, and at the speculative edge lie bubble universes, multiverses, and the open question of whether space ends at all, or runs on forever. The wall around us is real, but it is a limit on our vision, not on reality. The cosmos almost certainly doesn't stop where our sight does. It simply continues, quietly, enormously, into a dark we were never built to see. If your sense of scale just shifted a little, do me a favor, hit that like button. It genuinely helps these ideas reach more curious minds. Share this with the one friend who always stares a bit too long at the night sky. And if you want to keep journeying to the edges of reality with us, subscribe and ring the bell so you never miss what's next. Because the universe is far stranger and far bigger than it looks, and we're only just getting started. Until next time, keep looking up.